Hi guys, today we're going to working on the first time of chapter 7. My plan is this. I'm going to work on chapter 7 as we talked about before. I'm going to finish chapter 7 and I'm going to move on chapter 8. After finish chapter 8 if we have time. I don't think we have time though, but if we have a time, I'm going to go back to the chapter 6 to talk about factors. Okay? So chapter 7 is about matrix. So you guys I already gave you the review work for you to working on the solving systems of two equations because matrix is literally about solving system. Okay, so we already reviewed with the worksheet about method of substitution, elimination. I hope you guys don't have any problem on it, right? So for now, let me move on because I don't want to waste our time. So just let me know that if you don't understand it, let me go back and then explain quickly about what it is. But I think you guys are okay to solve a system. So let me just go to the section 7.2 now. Okay, so section 7.2, I'm on page now 530. Okay, so we're going to talking about matrix algebra. So what is the matrix? They are having the definition all the way top of the book, page 530. A matrix is a rectangular array of numbers. How can we make that? From the system. These are the coefficients. So we are going to pull all the coefficients out and we can make a matrix. So look at the definition of matrix. Let m and n be positive integers. On m times n matrix by m by n matrix is a rectangular array of m rows and n columns of real number. So you just confuse you that what that means, right? So we are going to talking about m by n matrix. And then this m always stands for number of rows or columns. They said rows. So this m always stands for number of rows, no exception, and number of columns. Just check it. You know what is rows and what is columns, right? Let's say you have a 1, 2, 3, 4, 5, 6. Which are the columns? This is column, right? So column. First column, second column, third column. And what is a rows? Rows is this. That's rows, right? That's what you need to know. All right, so when we are having m by n, you're going to have your matrix looks like that. So you always have a rectangular array. We're going to have a bracket. And then this we call the, element or entry. So this is, we call the A11, A12. So this A11, A12 stands for the element, which is a single numbers. So A11 is actually the first column and first row. A12, first row, second column. A13, and it is keep going until you're having A1n because I don't know my number of column. Now I have a second row, 2, 1, A2, 2. It's gonna be the same until you got what? A2n. Keep going. What's gonna expected? AM1 because this is my number of rows. And AM2 is keep going. My final one is gonna be AMN. So please look at the picture, which is the definition of a matrix. Then you can see the better picture though. Okay. So another way we can write down this one as a shorthand notation, which is A, which is for my element I, J. It is the same as what we just have it. Okay. So as I said, these all numbers A11, A12, A3 through ANN, that is what? Element. And then your second height of the word is the row Subscript is the first, subscript I, and column subscript is the second one. I told you always rows first and column second. So A11, first row, first column. A12, first row, second column. Okay? And then in general, the order of an n by n matrix is n by n. If have a chance that you are having same as mn, which is same number of rows and same number of columns, we call it as a specially square matrix. Think about it, square, they have all the same side. So you can, remember the vocabulary easily. Now, two matrices are equal matrices if they have the same order and their corresponding elements are equal. If they're exactly identical, then we can say they are equal matrices. Okay, so the first example, we're going to practice to determine their order of matrix. So you're given it looks like this. Matrix 1, -2, 3, 2, 0, 4. Okay, so we're going to think about the number of rows and number of columns. I told you always m by n. M stands for what? Rows. How many rows do we have? 1, 2. So 2 by how many columns? 1, 2, 3 columns. So 2 by 3. That's my first answer. Can you guys do that? So that's we call the order of matrix. All right, now the second part, a second question I got. 1, -1, 0, 4, 2, -1, 3, 2. Same way, always which one goes first? Number of rows first. 1, 2, 3, and 4. 4 rows. How many columns, guys? 2. 1 and 2. It's kind of really, confusing, but you guys are following me, right? All right, next one, C. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it has the same number of columns and same number of rows. 3 by 3. How can we call it? Square matrix. Okay? Alright, so I need you guys to work on exercise 1 right now. Okay, since I think it's easy, I'm gonna move on to our second question. Okay? So second questions is about matrix addition and subtraction. It's kind of easy, guys. It's just regular adding and subtracting. You could just adding the same elements, which is same element means they have a same location. So first row, first column, you're going to add those numbers together. First row, second columns, you're going to add the numbers together. So I'm going to show you the example. So let's say my matrix A is this, and my second matrix B, written like that. Now the first one, the sum of A and B, which is A plus B, is Aij plus Bij. What does that mean? I'm going to show you an example. So you guys need to know that they need to have a same order so that we can work with it. If they don't have a same order, forget it. We cannot really do it. So my A, let's say 1, 2, 3, 4. Okay? And then my B would be -2, 3, 0, 4. All right, then I want you to add them up. What do? Same locations, you're going to adding those numbers together. So my A plus B can be written like that. 1 plus -2, so same locations. And what is next? I have 2 and 3. It's going to be right here. 2 plus 3. Now I have 3 and 0. It's going to be go here because second row and first column. Now my last one, 4. 4 plus 4. Okay? Now what? Simplify. 1 plus -2, -1. 2 plus 3, 5. 3 plus 0, 3. 4 plus 4, 8. That's what I have. It's easy, right? Alright, move on. Now, second, I want to find what? Subtraction. So, A minus B. So, AIJ minus BIJ. That's what we have. Okay, I'm gonna using the same example, guys. So, what was my A? 1, 2. Okay, just make it smaller. Okay, so I can see. So, my A minus B this time. 1 minus -2. 2 minus 3. 3 minus 0. Make sure you're going to use the same number. Or only what the same number means this time. First row, first column, the same location. Now don't make a mistake when you simplify. 1 minus -2 plus 3. -1, 3, 0. That's my answer. So did you see that? Even if you add or subtract, your order does not change. A plus B still 2 by 2. A minus B still 2 by 2. Right? So let's practice our example 2. Wow, it's a huge matrix, right? You have a 4, 1, 2, 3, 4, 5, 6 rows and 4 columns. Literally just adding them up is not really hard. So instead of example 2, because that's too big number, it's really hard to write down everything in this screen. I would using another example in the back. Okay, page 540. Now I'm at page 540. Let me use okay, I want to give you 11 for your question. So I just make up on my own. I don't want to practice with the too hard questions now. It's not hard, but it looks hard because it had a lot of numbers. So I just, give you simpler one. Okay, just erase page 540. Okay, so my question for example 2 would be this. 2 dash. My A, 1, 2, 3, 0, 1, 4. My B, -2, 4, 6, -3, 1, 0. Okay? So before we start, can you tell me the order of matrix A and B? I know I'm going to say it, but I need you guys to think about it before I say. Number of rows, number of column every single time. Both of them, A and B, is what? 2 by 3 matrix. Okay, so A plus B, that's what I want to get it first. And I'm going to do the A minus B after. So A plus B, add all the numbers, which is in the same spot. So 1 plus -2, 2 plus 4, 3 plus 6, 0 plus -3, 1 plus 1, 4 plus 0. Let's go. That's -1 and 6 and 9, -3, 2, 4. That's what we have. Okay? So later on, if you get familiar with that, you can really, do your calculation easily. Let me just double check it there. No mistake. Okay. Now A minus B. make sure you don't confuse it with the sign, okay? Okay, so A minus B, what number do I have? 1 minus negative 2, 2 minus 4, 3 minus 6, 0 minus negative 3, 1 minus 1, 4 minus 0. Okay, so 1 minus negative 2, 3. Negative 2 and negative 3. And minus a negative plus 3, 0, 4. Let me double check it. So I have 1 minus negative 2 here, 2 minus 4, 3 minus 6, 0 minus 3, 0 minus negative 3, 1 minus 1, 4 minus 0. So which will give you 3, negative 2. That's negative. It's just dot. Negative 2, negative 3, positive 3, 0, and 4. Okay. Yeah, that's it. So I need you guys working on number 11 on page 504. Okay, so I hope you don't have any questions. Just let me go over and talking about what we've done it today, because this is our new lesson. So just let me go over. This is a matrix, which is a rectangular array. You always have a bracket, right? And then m by n, always what? M stands for rows, n stands for columns. And then the order of matrix, we always talking about number of rows first and number of columns second. That's example 1. And then the sum and difference of matrix, it's the same as what we are doing as a regular numbers, but make sure you have a same spot numbers. You're working with the same spots, like first column, first row, right? First row, second column. So just make sure that you're gonna work with the same spot numbers, and then answer of sum and difference, their order is not gonna be changed. So if you don't have a same order of matrix A and B, you cannot combine them, obviously. After you combine them with the same number of the same order of matrix, then your answer is gonna be also the same order of matrix you have it. Okay? So if you have any question, let me know that when we have a live session. Okay? Bye.